Hi everyone. So today we have another Codeforces round, and today we have an educational Codeforces round. So yeah, this one's also rated for Div 2 participants, and I am a Div 2 participant. So yeah, it will be rated for me. And there are already 20,000 people who've registered for it. So let me quickly check if my Sublime is working fine. Okay, I have this pre-written already. I don't know how, but still okay. Okay, let's remove this. Let's do this. Let's print 3. Okay. And I hope I am recording. Yeah. So another 20 seconds to go, and all the best to anybody who's giving this contest. Okay, and here we go. You're an upcoming movie director and you have just released your first movie. You have also launched a simple review site with 2 buttons to press upward and downward. However, the site is not so simple on the site. There are 2 servers, each with its own separate counts for the upwards and the downwards. Okay, and reviewers enter the site one by one. Each reviewer is one of the following types. Type 1, a reviewer has watched the movie and they like it. They press the upward button. Watch the movie. A reviewer 3 hasn't watched the movie. They look at the current number of upwards and downwards in the server and decide what button to press. If there are more downwards than upwards, then a reviewer downloads the movie. Each reviewer votes on the movie exactly once. Okay, since you have 2 servers, you can actually manipulate the votes so that the movie gets as many upvotes as possible. When a reviewer enters a site, you know their type and you can send them to the first server or to the second one. Okay, so maybe I can keep all the upvotes in one of them. Can I keep all the upvotes in one of them? I think I can. If I just keep all the upvotes in one of them, I'll keep sending that to the 3 1. Right. And is it written somewhere that they both have to have equal number of people? Separate count of downvotes. Okay. So I think I can have an upvote for all the 3s here. This way. Yeah. And I'll quickly read the problem statement again because I'm doing a very simple thing here. Okay, -1. Why did we have a -1? Maximum number of total upvotes. Okay. Can we just have the upvotes here? Okay, let me read it again. Okay, moving on to problem B. So you're given three integers a, b, and c. Find two positive integers x, y such that the decimal representation of x without leading zeros consists of a digits. The decimal representation of y without leading zeros consists of y digits, of b digits. Okay. The decimal representation of GCD of x and y consists of c digits. Output x and y. If there are multiple answers, output any of them. So the next t lines contains three integers a, b, and c, the required lengths of the numbers. It can be shown that the answer exists for all test cases under the given constraints. Additional constraint on the input, all test cases are different. Okay, so for each, okay, you have something strange here, like test cases are from 1 to 285. Okay, and also like they've told you that C is less than minimum of A and B. Yeah, that makes sense because the GCD will definitely have less number of digits, will it? And what do we need to print? We can print any x and y here. Okay, A, B, and C. The GCD should be a two-digit number. Okay, and they can be from 1 to 9. C into B should have 3 digits. And C into Q should have 3 digits. Also P comma Q GCD of this should be equal to 1. Okay, 3 digits, so I can take 1 0 0 0. And then if it says 5 digits, then I can say, then if it says 7 digits, Okay, so let's say if c is greater than 0, greater than or equal to 2. Let's consider this case first of all. Then we have infinity a2 equals to expo. Then I need b digits here, so I can take like 7 times b1 equals to expo 10 comma b comma infinity. Okay, then I need to multiply this b1 with a number that has how many digits? If b is greater than a, then you swap a comma b. So int digits equals to, how many digits do we require? We require b minus a digits extra now. Rather, we require b minus a plus 1 digits. 7, 14. Rather, we can have 749, 343. 7 into 7. Rather, let's take it. Or can I take it for 3? A equals to 3. A into a. Then you have a into. Okay. A equals to a into a. A equals to a into 2781. Okay, let's try this out. Four digits, 5 digits, 6 digits, 7 digits, 8 digits, 1, 2, 3, 4, 5, 6, 7, 7 digits, 8 digits. Then you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so you always have this condition. Why did I have 10 here? C equals to C equals to 2. Why am I getting 2 here? Okay, let me see. I don't know why am I getting these invalid values here. Okay. I think I did a mistake here. Uh, 10,81. Why did I have 81 here? B minus A plus 1. So I want 2 digits. In fact, I want, how many digits do I want? B minus, no, it should have this now. The GCD will be 1 here. Here the GCD will have length 2. Here again it will have length 2. Then again here it will have length 1. So I think this is fine. Let's keep this 9. Let's keep this 9 and let's keep this 9. Okay, then you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this seems fine. The GCD will have length of that. Like I'm considering the GCD as wrong answer on test 1. Why? Oh, it should have been of length 3 here, right? So how much did I have? It should be C, B minus C plus 1. $729. Now it seems fine. Okay, wrong answer on test 2. What I'm doing here is that I'm considering my GCD to be a multiple of 10, like to be a power of 10, to be precise. Okay, let's look at it again. Let's print M1 first of all, because then we'll have an idea. For 1 it has 9. For 2 it has, like, these are the number of extra digits that we require, right? Okay, for 4 we have this, for 5 we have this, 6, 7, 8. 9, 10 and 11. So this is like a multiple of 3 and this has only tens in it. Okay, if B is less than A, then I'm saying that you swap what am I getting as the answer? Let's see. Oh my god, I did not swap them later. Then what if I don't swap them? Let's look at this. Okay, let's try to submit it now. What if I have 2 here? It should be 8, 10, right? It is okay. Let me check it once more. Counter equals to 1. Okay, fine. Okay, great. So moving on to problem C now. You have a card deck of n cards numbered from top to bottom. That is, the top card has index 1. You should process q queries. The jth query is described by integers tj. For each query, you should find the highest card in the deck with color tj. The card with minimum index. Print the position of the card you found. Take the card and place it on the top of the deck. Okay. The number of cards in the deck, the number of queries. Okay, so for each color they are saying that you can have at max 50 colors here. Okay, this is something to notice, that you have at max 50 colors. Okay, then can I create 50 binary index trees here? I don't think I can. ith card has color AI. You should process q queries. The jth query is described by integer tj. Find the highest card in the deck. Okay, so we are only concerned about the highest one. Okay, we don't really care about all the others. So if we have highest, and if I pick this, the thing is that the highest card is never going to change. Like, it will always remain the highest card, right? Yeah. Okay, great. So we're done with 3 problems, and like the third problem was a really easy problem compared to the B problem. So moving on to problem D now. Okay, let's define the cost of a string S as the number of index pairs I and j such that Si equals to Sj and Si plus 1 equals to Sj plus 1. Okay, you're given two positive integers n and k among all strings with length n that contain only the first k characters of the Latin alphabet. Find a string with minimum possible cost. If there are multiple such strings with minimum cost, find any of them. Okay. N and k among all strings with length n that contain only the first k characters. So it is about arranging those k characters. It is always beneficial to include as many characters as you can. Okay. Given two positive integers and Si equals to Sj and Si plus 1 equals to Sj plus 1. So if we consider like pairs, that if I have A and B, so as many times as I have A and B in the whole string, I will have to add up the answer that much. And in fact, it will be like if there are n pairs of A and B, then you will have n into n minus 1 such not n into n minus 1, n into n minus 1 divided by 2. Number of such pairs. So if I have A, B, I can consider all the pairs, like how many pairs will be there. There will be like 26 into 26 pairs, right? Yeah, these are the number of pairs. That is like something 676, I guess. Yeah, there are 676 total number of pairs. And now it's like we have to arrange it in such a way that we use, let's say we use the first pair 5 times. Then let's say we use the second pair 7 times. So overall, like, and there will be some overlaps as well, right? Yeah, if you have A, B, and the next character that you put here, that will also become like that. Okay, let me think about it while roaming around. Okay, let me look at the sample test case here. A, B, D, B, B. Okay, so like looking at the sample test cases, I sort of have a construction here, and a construction is like this. Obviously, this is a greedy approach, and there isn't like any proof that it is obviously the optimal. So let's say I have k characters. So what I'll do is I'll put my first two characters as AA, and then I have my starting character as A, right? So then I'll pick another character and I'll have to pick character from A to so on up till K. Let's call this K only. Then which number will I choose? So let's say if I choose B, then I will have some occurrences of AB, right, already. So if the occurrences of AB are 0, then I can obviously put a B here. It does not harm me. But should I put a B here or not? That is the point. Like if I put a B here, then I can also put a C here, right? And let's say I already have some pairs like BA, BB, so on up till BK already present. And I don't have, let's say, CD already present. So then it is always optimal to choose the C, right, here. Because then the next character can be a D. Right. So I will choose the character. First of all, yeah. Do I also have to print the score? No. So I will choose a character such that if my last character was A and I choose X, then the occurrences of AX are minimum. Also, if there are many such candidates for which this AX is minimum, then I choose the one for which AXP, let's say, is minimum. But how is this going to help me? Like here what I'm doing is I'm sort of distributing it in the whole, in all these pairs. I'm not accumulating on one of the pairs, and that is always helpful when you have when you have to consider pairs. So I don't know, like this is just an intuition that this will work, and I'll have to see. Okay, so let me try this only. Other test cases? No, there aren't. Okay, I don't need this. Rather, I can take it only because it will be beneficial in then verifying it. And priv, rather I should take char equals to a at index. Okay, then what do I do? Okay, so if min used is greater than ARR at number comma j, then min used let's keep this. Okay, AAAB, BC. It should have been BA actually. If ARR at number comma ARR at number comma index 1 is greater than Oh, okay. I'm not sure about this one because, yeah, like this is just a construction. Maybe there is some other optimal solution. AA okay, seems fine. Let's try to submit this one. Great. So 4 problems are down. This was like, I don't know, it was a tough problem for me. And I'm not really sure about the intuition still. Like maybe it might get hacked. Okay, but anyway, moving on to problem E now. I hope the pre-tests are very strong and this does not, fail on the system tests. Okay. Moving on to problem E now. Colorings and dominoes. Dominoes. So you have a large rectangular board which is divided into n into m. I hope it is getting recorded properly. Yeah. You have a large rectangular board which is divided into n into m cells. Each cell is either white or black. You paint each white cell either red or blue. Okay. You paint each white cell either red or blue. Okay. Obviously, the number of different ways to paint them is 2 to the power w. Fine. Then what do they say? Then they say that after painting the white cells of the board, you want to place the maximum number of dominoes on it. According to the following rules, each domino covers 2 adjacent cells. Each cell is covered by at most 1 domino. Okay. If a domino is placed, okay, the domino is like a 2 into n, 2 into 1 type of a rectangle. So if a domino is placed horizontally, it covers 2. It should only cover only red cells. Let the value of the board be the maximum number of dominoes you can place. Calculate the sum of values of the board over all possible 2 to the power w possible ways to paint it, since it can be huge. Okay. Let the value of the board be the maximum number of dominoes that can be placed. Okay. So one thing to note here is that the horizontal dominoes are only covering the red cells. So they are sort of like independent, right? Yeah. The red cells and the blue cells are sort of independent, right? Okay. Let me think about this. I sort of have some idea already, but yeah, I will have to think more about it. Black and white. Okay. Let me think here. Okay, so like the thing to notice here is that these red and blue cells are independent. So I can consider my grid as to be first of all horizontal, and then I can just take the transpose and calculate the answer again. So let's say I'm talking about this row. So let's say these are white cells. So they want us to calculate the maximum number of white cells that will be present after we color. I mean the maximum number of dominoes that can be placed after we color this. So what I'm saying is that I'm just making a generalization that if I have my array as this and these all are blue cells, then I will put my domino on the very first cell. It does not harm us to put the domino on the next one and here. It does not harm us here. Like if you have 5 blue cells, then you can do it like this, and you can also do it like this. So it does not harm us. Like I'm saying that without loss of generality, I'm taking the first cell as the one that will be marked. So I can consider it like a contribution type of a problem, that how much will this 2 cross 1 cell contribute to my answer. So both of them first of all should be blue. Secondly, if there is already a black cell here, then I don't care about anything else. The answer is simply just 2 to the power, let's say n white cells are present, then 2 to the power n minus 2 here, and obviously these are fixed. If there is only one white cell here, then what I want here is that it should be colored red. So that is also fixed, and then I will have 2 to the power n minus 3. Okay, and if there are two white cells here, then I would want a domino to be placed here. So that would be like the number of ways here, but that would have considered that I would have tried all the possibilities here, so I will have to divide it by 4. Okay, seems logical. It might take some time to implement, and I just hope I have read the problem correctly. Okay, let me just make a function here. Bytes in each row. What are these white cells? The white cells are star. Is it an O? Yeah. If here are at I comma j minus 1, j is less than 0, equals to 0 or y it's at I minus 2, then you will have, it should be 2 to the power, then you have mod 1, else if here are at j minus 1 equals to j minus 2. 144. Oh my god. This is insane. Let's try to do it for the first one only, because then it will make sense. This is for the first one, this is for the second one. How can there be 144? I think I misread the problem. You paint each cell either way. It should only cover red cells. Placed vertically, it should. You paint each white cell either blue, red or blue. Obviously, the number of different ways to paint is 2 to the power w. Okay. So here, total ways to paint is 2 to the power w, and it will be 2 to the power 32. I mean 2 to the power 5. That will be 32. So they are saying that there are more than 32 dominoes that are getting formed. Okay. Okay, it is actually black. Okay, I did it totally wrong. Four ways here. But still, like, there cannot be many ways to paint that thing. Yeah, it is only giving 7 here. Covers 2 adjacent cells in one of the columns. It should cover only blue cells. If the jth cell in the ith row is black, otherwise that character is a no. Okay, let's look at this one. They are saying that you can place 9 dominoes here. How can you place 9? The other ones you do whatever you want to in that case. Okay. Four ways to form a domino here. Then here you have to place a red cell. So if it is black, then you know if j equals to 0. Okay, fine. Then if j equals to 1 or then also you're done. But otherwise then you have a domino here. Okay. So you can have a domino here, and what if you don't have? Let me think about this. Okay. Okay, seems to be working on the first test case. That is a good sign. Working on the second test case as well. Let's try the third one. And yeah, I had already tried the third one. Okay, I think I copied the same thing. So let's try on the fourth one. 9. Okay, fine. I'm submitting this now. So let's see. Obviously, I haven't spoken much about this because like there was a lot of thinking involved here. Let's see. Finally. Okay, this was great. This was really great. Yes, okay. So the thing here is that none of these solutions should fail. Like ideally they should not fail, but if they do, then my rank will like increase by a lot. Okay, I don't think I will be able to do the F problem here with the amount of time remaining, because obviously like people who've done it before me, people who've done the E problem before me are not able to do this. So I don't think I will be able to do this one. So yeah, I'll be quickly ending the recording in some more time.